Sorry. Hello, good morning, good afternoon, and good evening. My name is Zhijin from Peking University. Welcome you to attend the plenary panel, which is going to discuss about the advances and challenges in software service engineering. For this panel, we have invited 8 panelists. They are Ka Chang from Ivan University, State University, Paulo Serravola from University of Milan, Rong Chen from IBM Watson Research Center, Sumi Hela from University of Florida, Xuanzhe Liu from Peking University, and Hua Min from Auckland University, and myself from Peking University. At first, I would like to invite Ka Chang to introduce a little about the history of this panel. Let's welcome Ka. Yeah, welcome.
Hello. So I would like to first to offer a historical perspective of why we're here, why we're here today having this panel. Also, you know that this is the plenary panel organized by the symposium called the International Symposium on Advances in Software Service Engineering. The early days when we have software engineering back in 1968, when this term was coined, we have come a long way. From the early days, we build, for example, we write assembly code, right? In the early days, from building the routines, and then gradually we move into modules, functions, and then into the object-oriented paradigm. And then we build a component and to a larger and larger software elements. So, and in the same time, the software engineering profession has moved from proprietary to open source, and moving from closed system to nowadays more and more into the open system. Service computing revolution is later, of course. Service computing evolution started from maybe the end of the 1990s and the early 2000s when we start talking about service computing. And the services has now evolved into the microservices, and we evolved from the service-oriented server client style to serverless, and also the profession has also adopted different kind of service computing operational mode, from private to public and so on. So in all these years, service is actually not a new concept. We know since the old days, service, for example, when we design the operating system, we actually build the kernel to provide services to the outside layer, layer by layer, like an onion ring. And the networking is the same thing, is follow the same spirit. And then in both software engineering and service computing, we talk about API, middleware, and so on and so forth. So there's actually a common root for software engineering and service computing. They followed a path towards what I call a crazy convergence as it comes to nowadays. The earliest literature, we can that's more relevant to what we're talking in this panel. I think the service-oriented software engineering work in 2005 by this group probably is probably one of the earliest that start using the term called service-oriented software engineering. This work is focusing more on the alignment of business objectives, operation, and processes. That sounds familiar to people working in service computing. And also, of course, they talk about software engineering, so that the using software engineering methodologies to deliver quality services in a more organizational, with more organizational efficiency and improve the economy. Then moved it forward until 2009 in this Dextool seminar. They also published a paper after that seminar in this IEEE workshop. They started using the term software service engineering. In this paper, defined the 7 principles and enumerate some challenges in this new so-called emerging discipline, software service engineering. In this 2009 paper, they actually gave a definition. We also kind of use the definition as our working definition here. But you look at the definition, it's really broad. It's basically a science application of concept, model, methods, tools to design, develop, deploy, test, provision, maintain. Here the keyword, business aligned, just like the 2005 paper, more in terms of business objectives, business processes. So it's more business aligned, and the SOA, here's the keyword, so service-oriented architecture in a more disciplined, reproducible, repeatable manner. So this sounds more like a software engineering definition, although they start focusing more on the business alignment, also the service-oriented architecture, which is one of the key components sustaining the service software service computing. Then until last year, there was a plenary panel organized by Elena Ferrari, used this title, Software Service Engineering and the Ecosystem Evolution. In this panel, it says, is a summary, it says emerging application areas, the things we are talking about these days, intelligent medical applications, smart cities, cyber manufacturing, which is the keynote this morning, and all these intelligent resources and so on. Here is a keyword, is a self-awareness, self-adaptation, auto-healing, auto-repair with low human intervention. Try to get rid of human intervention. So, and talk about some of the novel software development and development practices, such as DevOps and so on. So this is much more recent than 2020, last year. And so why we think this is time for us to launch this inaugural symposium on advances in software service engineering? We think by now, many software engineering professionals and researchers, we are actually inevitably already engaged in service computing. I'm, for one, myself. I think many panelists here today that are also involved in service computing, otherwise they won't be here. And some actually got engaged, but they are not really even know they are already so much engaged in service computing. And many other advances in other disciplines, including, for example, AI, machine learning, brain science, neural computing, psychophysiology, high-performance computing, just to name a few, begin to find a way to cross both software engineering and service computing. So really, we're talking about a common ground for professional scholars from both domains, software engineering and service computing, to come together, cross-fertilize our work in two different ends. But we try to congregate together, so we are seeing more convergence in the landscape. I think we have already reached to a critical mass. I think that's why we think this is a good time for us to start a new symposium and start expanding on what we have learned in this crossroad between software engineering and service computing. So welcome to this panel, also to this symposium. I just would like to bring to you bring to you awareness of a white paper we actually composed together with all the panelists here in this panel. It's called a Software Service Engineering Manifesto, a cross-cutting declaration. This is a paper published in the ICWS proceeding this year. in the section called ISASE, or International Symposium on Advanced Software Service Engineering. In this white paper, we observed 7 key area, key themes, and we make certain declarations, basically to sharpen the focus on the challenges that we are facing in software service engineering, and also the opportunities that lie ahead of us. So in this paper, we also have architecture layout, like this stack view of the software service engineering. And even with only 7 of us here, we can only touch base, not the entire architecture, but only focus on the area we are most familiar with, are capable of talking about. So in the following, in the remaining time of this panel, you're going to hear us talk about each thing individually. With that, I would like to stop here, stop sharing, and move to our next speaker, Sumi Halal. Sumi is going to share his screen and going to give us an overview of the software service engineering in the IoT era.
Good morning, good afternoon, everybody. Carl, thank you for inviting me. I appreciate the invitation. I have, I think, 6 minutes. So I think my presentation is being shared now in a second. Very good. Next slide, please. So just echoing what Carl has mentioned about why are we here today, why are we talking about software services engineering? We are doing this because, as everybody has said, and also last year's panel concluded, we have taken computing out into completely new areas. Many of them are human-centered computing areas, and also we have taken computing very close from the real world, where Internet of Things created these wonderful, ubiquitous, and pervasive systems, and we're still trying to compute using the same sort of assets and practices that we have developed, particularly in distributed enterprise computing. So we're taking the same asset for targeted enterprise computing and take it into really different areas. So that's why we're here today, to ask ourselves if the assets we have are adequate or they need to be changed. Next. So they need to be changed. And the reason is we have new challenges brought about by these new areas of applications. And most of these challenges, you can look at them and describe them as basically bringing new elements in the loop. So the human in the loop. How can you put a human in a pathway of a chain of services? That's different. The human is very different from a software service. And same thing for Internet of Things. You're bringing the entire real world into the loop. And there are a lot of things that you cannot control, and there are a lot of things that are uncertain in a way. So these new elements getting in the loop, simply challenging the status quo and sort of demand a new agenda so that we're able to do services right and to fulfill these applications. Next. I'm looking at my timer here to make sure I'm good. So services for distributed enterprise computing, which follow traditional software engineering principles and practices, fall short of supporting the development of human-centered and IoT-based systems. That's the situation where we're in. Next, please. So it's not like we just woke up one morning and discovered the problem. That's not the case. What happened is we have been trying to solve this problem, but we really haven't gone or advanced far enough. So microservice for the Internet of Things. A little history here is that we started with a humble beginning where we just wanted to make sure that devices and IoT things are services. Just make them a service, make them look like a service at least. And for that, there were a lot of early development. SODA is like a term that IBM coined at some point to describe these standards out there. try to make a device look like a service. And the picture here is not showing on the screen for some reason. It's not very important, but what is important here is that these devices were capable of self-APIing themselves by establishing what's so-called endpoints on the cloud or the edge. That was like what SODA is about, service-oriented device architecture. There are a lot of standardization efforts. Many of them succeeded. Just a few adopted, some failed. And the Atlas architecture, that's the work I have been doing with my colleagues and students in the University of Florida, that came out in 2006. 2012, ARM Embed OS, which is a major development. That is, in my own view, the first official operating system for Internet of Things. ARM Embed OS came up with the device cloud services, where in addition to programming the ARM chip on a small board like Arduino and Raspberry Pi, but these will be an ARM embedded architecture like Cortez. Instead of doing this, or after you program that board, you still have the option of programming a representation of that board up in the cloud, and that is called device cloud services. So what has been achieved as a humble beginning is enabling service-oriented system development approach. We don't call it service-oriented software, or we system, because there's software and hardware, where you are able to seamlessly integrate hardware with software. And that gave rise to some DevOps, particularly smart spaces and smart homes. Next, please. So SODA was great to just get devices to look like software services, but it wasn't good enough. It wasn't enough to sort of bring services to where human-centered computing and the IoT, with all its ambition and the blue sky vision that we have been having, to be fulfilled. It was just a small beginning, just bringing devices to look like services. Context-aware computing came along and really tried to sort of do a better thing than SODA, make it smarter, make it more conditioned, and sort of make it particular, give it some little semantics. And that also helped a lot. But the avalanche of the blue sky vision about the Internet of Things, the kind of imagination we had and the aspiration was so high that even context-aware computing, stood a little short of meeting these demands. So the blue sky vision demanded much more transformation out of the service-oriented model and architecture themselves. We needed to sort of put pressure to think of how we change it, what is missing, what new elements need to be added to these service-oriented model and architecture. Next. So quickly, just to try to explain what happened and where we are now. So SODA is here, seamless integration, easy programming model, which is wire graph, just service composition. And also SODA was great, but it has horror stories. And I'm not gonna talk about the horror stories, but you can read about them in this short paper here, the monkey, the ant, and the elephant. But that's SODA, was just a beginning. And then context awareness came to add semantic conditioning, and also to make the service adaptive in its delivery. And that led to much better services, more usable by people like the HCI communities. They started to use service SOA at that point, and that was a good transition. But today, given the vision we have been seeing, guided by these anecdotal blue sky visions, the requirement we see here, or the evolution path, is that services actually become just a new actor, a third actor, in addition to the user and the developer. The service line up with them, become that active, become that conscious about everything, about themselves, about others, about the possibilities, about the opportunities. So that elevation of a service to become a new actor in that array of actors is the big thing that I envision it to be guiding us in our sort of evolution in the service model. So I said self-awareness, peer awareness, and also collaboration. We can go to the next slide. So self-awareness quickly is try to push some kind of responsibility on the vendor that create the IoT things. And here we're trying to make things to be aware of its capabilities, its features, its runtime constraints, and the kind of relationships might have with the rest of the world. So that's consciousness of own capabilities and relevance. And several sort of groups started to work on this, including my group, working on what's called device description language, which is some description that the vendor inject into the thing, and that provide the genetic elements so that when that thing is playing, when it's powered up in a system, it reflect and inspect its own sort of genetic elements, its own information, and become conscious of all these elements at runtime. That really engages the vendor to become a contributor, even in the development of application, because application now, any application that uses that thing must include code developed by the vendor, bits and pieces of code. So that bring in, that sort of disrupt the role model of who is a programmer, who is a developer. Now they have to be developers. I have a link here for a specific thing about this language. We can go to the next slide. That was self-awareness. That's an example of just a snapshot of a thermometer and how it can be described to make it self-aware. When it's powered up, it knows a lot about itself, be ready to play in a services platform. Next, please. Move to peer-aware and collaborative. So peer awareness has to do with autonomic socialization. So that's where things start to reveal a little bit about each other, they reveal to others, and also try to learn about others. So that's like socializing by tweeting, chatting, nothing in way of ontological structure, but rather just loosely communicate to understand the opportunities, understand who's out there. So to be conscious of others, that's peer awareness. And that prepare them collectively, things collectively. Now that they have had some awareness about each other, now they can actually be in a position to also be one more programmer, to take on the role of one more programmer. I call it the cybernetic developer, because they can actually see what can be developed, even if not a complete application, but nuggets of application, opportunistic bits and pieces of potential application that the user himself or the developer can use. So they can really help in becoming part of that DevOps ecosystem. That's really disruptive in many ways. Next, please. So we worked on something called the Atlas Thing architecture, focusing on the thing instead of staying in that blue sky level talk about vision. We wanted to go down and walk before we run. We just wanted to zoom in and find an architecture that's supportive of these new elements that I'm talking about before: self-awareness, peer awareness, and collaboration. And we created an architecture, but I don't have any time to talk about anything here other than saying that that architecture is service-oriented, of course, similar to SODA, but the new thing is it is conscious of what's called inter-thing relationship. You may have heard of if this, then that, FTTT, for example. It utilizes relation one, which is control. But we found 7 relationships, and I'm presenting 6 because the 7th is controversial. We found 7 relationships that we feel are canonical, are essential. So a meta ontology can describe them, and that's not a domain ontology at all. So these relationships can sort of help make that kind of model happen or be realizable. Next, please. So just to give you more, I've been talking at by referring to things. Here are just 2 examples quickly. We have coffee makers today that have time services and have these buttons, 3 buttons on the bottom and a clock. Redundant time service. The house has a lot of clocks. The house has an owner who is a smartphone. The smartphone has the best time service, but we're ignoring that. So tomorrow, what we should have is coffee maker should just not have a time service because your phone has a time service. So you use that quality time service by interaction between the 2. So if the 2 are in the same smart space in your apartment or house, they already buddy up and socialize and know the capability. And that prepare things in a way. So when you set up the alarm to wake up next morning, in the clock application in your phone, the clock application now give you the option, say, hey, looks like you have a coffee maker. Would you like to program it? Would you like me to set it for you? So these kind of scenarios should not be far thought. They should be the standard if we keep talking about IoT. We just have to have the right services model so that we enable them. Next. That's a very powerful example because it really describes almost everything, self-awareness and also peer awareness and collaboration, which is a World Cup IoT scenario. Every World Cup comes in, you find all these fantastic apps, and you can drill and see the games and game statistics. You can see the games coming ahead, and you can see that you will miss that game, and you want to record it. So what you do is, you have a smart home, you have a smart TV, the Samsung Smart TV, you have a smart DVR, digital video recorder, you have a smartphone with apps, you have everything smart, everything is connected, but no cigar, no IoT. And what you do is, now you see the information about the game, you get the basket of remotes and try to get remote, try to schedule your game. So the user here is acting on behalf of the future of IoT vision that we're looking at. In other words, we don't have IoT here. That's horrible. So what we need to do is, we need the apps that you have and all these smart things to buddy up again, socialize, be aware of themselves and others, and then now understand the opportunity. The DVR, say I record sport and I record game and sports event, and the app understand that is dealing with sports event. They already buddy up and get very ready to help the user here utilize them all together. So we create, next please. So we created a proof of concept of how to do these things in Mobicom, and we put it together in the hard way, by hardware, assembling hardware, and actually demonstrating how that can happen, where the mobile application even changed. The developer who developed the app didn't include any features about TVs and recording anything. But now the IoT itself is adding that code and making these things happen. So we demonstrated that in Mobicom only to realize how to do it really well, and we fulfilled the full scenario completely using what's it called, MAT. Next, please. So MAT was the additional requirement, which is, okay, great. So microservices, you also need to make mobile apps microservices. So we call that mobile app at thing in the IoT, mobile app at thing, MAT. So we actually developed MAT, and in developing it, we realized that we need to have something called actionable keywords. Keywords that try to help matching is one thing, but since we're saying we're putting live in making services conscious, you can imagine that what we used to call keywords in the past now has to be something with more live in it, and we call that actionable keywords. And that actionable keywords, next please. We have that actionable keyword is just represented quickly by these three shots here, where you have an app with this is the original app, has games, and all of a sudden, because there is peer conscious, you see a new gadget on the app started to develop. And as it's being developed, you see that progress bar here, the red, and then on the second middle screenshot, and then the third screenshot to the right, you see now that you have these gadgets already built, the switches. So the developer never included these buttons or that has watch on them or record, but that didn't happen. So I think I'm running out of time here, but just showing you that you can take that concept of conscious microservices to a great level that really try to enable these blue sky vision. So we have to continue to think of blue sky visions and look back at our assets and the SOA and the services model and the software engineering practices that back them up, and ask ourselves what is missing, and how can we prepare ourselves to really become relevant and cater to all these new applications. Next, please. So I close here by saying we need to raise the bar on services to meet the new requirements forged by IoT and by human-centered application. Second bullet is, for such emergent type of service. Many software engineering practices need to be revised, updated, co-designed, and integrated as the new microservice requirements are understood. So what I presented to you today is not really like a wise or a full understanding. It is just a beginning of understanding this, and a lot need to be done by a much larger community. But I'm just presenting to you some of what my group believe is relevant here, or is a potential first step. But I have to caution you, because these drastic changes will challenge status quo significantly, perturbing the programmer, the developer model. These are drastic changes, so we have to do it very carefully, and we have to do it by trying to achieve progress while not perturbing the traditional asset and the traditional application domain. The distributed enterprise computing has to continue to thrive and to further develop. So we have to do that very carefully and delicately. I don't know how, but we have to do that. Thank you.
Yes, thank you, Sumi. So Sumi mentioned a very important keyword, which is human-centered. He also mentioned about things like HCI. And also Sumi is talking about the context awareness. For some of you probably heard about some of my work. Now I work a lot in the situation awareness. Okay, and in this case, I call it situation analytics. I have published some papers in this direction. So what do I mean by situation awareness or situation analytics, and why it has to do with human-centered computing? The reason is, the prevalent wisdom seems to be to keep human out of computing. And human is unreliable, human is ambiguous, and they feel insecure, and the human even lie sometimes, right? When you talk about the requirements engineering, you may not always get what the user really want, because the user, the customers may not want to tell you everything what they want for fear of maybe you want to charge more or something. So human being is very imperfect. So we like to get a human out of computing, and so that we can achieve a greater autonomy. So that's why we had worked a lot in autonomic computing or autonomous computing. It seems we have already gained much ground. So this is our prevalent wisdom. It is true. It is correct. It seems to be the direction now. We've been lots of researchers and people in the real world are trying to work towards full autonomy, and all try to at least try to keep human interference to the minimum. The truth is, okay, I think that statement that we just shown in the last slide is actually a mystery. I think the fact is that my personal opinion is that there are many service computing professionals and software engineering researchers, especially for those who work in the human-centered computing aspect, they fall short of taking advantage of the promises and opportunities afforded by advancing in other fields. Okay, I mentioned a few in the opening, such as in brain science, for example, such as in psychophysiology. People start making lots of progresses in those fields. The truth is that the emerging IoT era, including using humans as the sensors, can afford what I call the human embedded computing. Okay, if not human-centered, no, this is probably is more human will get more involved in computing actually end-to-end, involved in computing even after the system has been deployed. Because we have those advances in other areas that we know we can take advantage of, such as neural computing, right? So maybe 10 years from now, some say 5 years, that we can already have this device. We can be as small as a earbud, put in your ear, be put into your hearing aids, will be able to capture your brainwave. And through the techniques such as machine learning, the brainwave can be interpreted. Okay, can be intercept, not from any kind of implant into your brain, but just from your earbud. Okay, from your hearing aid. We'll be able to tell whether the person is pleased or not pleased with your the service you are providing. Why this is important? Because for some people with, for example, the people paralyzed from head down, they cannot even tell you, they cannot express themselves. We can actually tell what the person is, whether or not your services actually meets their needs. Actually, also in real time, after system the service has been cut over to serve the customer. These kind of advances in other areas is really eye-opening for myself, and I start looking more into what we can do with such kind of opportunities. So human embedded computing means that the human can be embedded in not just in the requirements phase, not just in talking, by talking to the customers, and then we get the requirements, and then we put them aside, and then they wait until the system is deployed. Even after deployed, how fast, how your customer can give you the feedback instantly. And actually, there's another term I call the instant requirements. How can we capture requirements instantly, maybe even on the fly? This sounds like a dream, but no, we are actually doing lots of things along those directions. For example, if nowadays if you go to Amazon or in Alibaba, these vendors really want to know what you like or dislike, right? So your keystroke on the keyboard has already been captured by this kind of tools using many different kind of techniques, including your keystroke, including the pattern, you're browsing the web, including your facial expression. All this can be used as a cue for the service providers be able to provide a much better service and to work, and also be able to meet your needs, or they try to understand better what you desire is. So I have done some work in this more formal definition of what we mean by situation. In my definition, situation is a strict tuple. I call it DAE or MAE, mental state. Okay, here I said desire. Desire is one kind of mental state. We have already come a long way to try to capture environmental context, and we have many different ways to capture behavior context, right? So in order to provide human-centered services, we have to understand where the person is situated, what kind of environment the person is in. And we try to understand from his behavior, try to capture behavior in order to understand what the person's situation is and what he really desires, what he really wants. So this is what I mean by situation analytics. I think this area of work allows to be able to really move forward, not to always think about put human aside or try to avoid human intervention. Actually, we have already advanced enough that we can afford to have human intervention, and then be able to really capture what the person really is, and what the person really wants, and what kind of situation the person is really situated. That I just would like to provide a little bit more in-depth explanation what we mean by human-centered, and in this case, human-embedded computing. So with that, I would like to stop and pass the podium to the next speaker, Minghua.
Thank you, Professor Chen. Can everybody hear me well, right? All right. So my topic today is basically to kind of realistically land this new paradigm, theoretical paradigm Professor Chen just mentioned, into the real world ground. So my cutting point is the functional paradigm situation. to kind of really realistically land the theoretical model that Professor Chan just described in his speech. And I also personally saw the potential of this functional paradigm as a foundation for future software services engineering. So I started with some very realistic example. So in Java program, everybody knows that if you actually use the print statement, all right, and even though you print two different things, like hi and hello, but the system will treat them as the same thing. Why? Because the print return a value of void type. So the void type contains only one value. So if you check a little bit of the Java language, you know that. But that's not really what we saw. We saw two different strings. They're not the same printed on the screen. So this is really the sort of the side effects. And in functional Haskell language, they actually use the monad type to sort of encapsulate this side effect into the return value of a functional expression so that you can reason and compare them. So as Professor Chen just mentioned, in a situation, human desire can be captured, in my perspective, realistically, as the side effect using a functional paradigm. So not really in Java, because Java is, as you can see, not a good fit. But then what is the best or a better choice? So I would say a functional language could be one of the candidates to serve such purposes. So as you can see that this program below is the Java program. It's very hard to understand and maintain, of course. This one, somebody use XX. We don't know what it is. So if some more kind of disciplined programmer come in and actually rename it a little bit, and then you understand it a little bit better, because this one means you square all the numbers between 0 and n and add them up. So that's sum square. But still, you have to go through this piece of code, read the while loop, and understand each and every step what it does. So why is it so hard? Because it's imperative. Imperative means you tell computer each and every step once needs to be done. But then it's needless to say, because of that nature, hard to understand, hard to maintain still, even though you use the right term to name the method, to name the variables, the difficulty still is there. So more importantly, sometimes some kind of bugs may creep into it. So you can see that if you miss out the equal to, it just put less than, then you actually face the off by 1 error. So this is basically why it's so hard to get it right, right? And so as I summarize here, it's easy to get wrong and a lot of code. So to describe a situation that includes rich semantic contents, we can really not rely on this imperative paradigm like Java language, right? Comparatively, a functional programming language, as you can tell, that Python, Scala all support that because they are multi-paradigm language. So make it so much easier. So equivalently, you can see that this one-liner above is equivalent to almost 10 lines below. So why is it equivalent? I just quickly go through that. You can see it very easily. And that is the map is a higher order function. You can think about it as a throw in. So throw in what? Throw in the square. Square is the function that will actually time one thing together with itself. So that's why it's called a square. So it's intuitive and succinct. So after a little bit of understanding and training, you can get this easily. So this map function will throw in the square into this list that contains 0 all the way to n. And then, so because you square 0, you get 0 square, you get 1 square, all the way to n, you get n square, right? And then you sum them up. Then what you get is really 0 square plus 1 square plus 2 square plus n square. That's exactly what this Java code, 10 lines of Java code does. So do this exactly the same thing, but the above functional paradigm, only 1 line, below 10 lines. So to describe things that are complicated, containing a rich semantic content, I feel like functional paradigm can play better in this kind of game. So what I would like to say also is when we compare these two paradigms, you can see the above, that's the functional paradigm. It's really the science. I will actually just talk a little bit more later on. And the below is kind of engineering. They're closely correlated, but science has a kind of stronger summarization power. That's number 1. Number 2, it is also big data science. The big data is because you can see that this list, it can easily be extended to two-dimensional list or three-dimensional list. Well, three-dimensional list is just a list of two-dimensional lists and recursively, right? And so in big data, we all are very familiar with this matrix. And the matrix is just a list of lists, if you actually think about it this way. So it has a very good support for big data-oriented science, right? Matrix, as I pointed out here. And I just make a little bit of correlation so you can see easily. When we replace 0 all the way to n with kind of a list or list of lists, you can see that this has a very good potential to accommodate big data. And so map, as I mentioned earlier, you can think about it as a throw-in. It's really a higher order function. The reason it's higher order because the first argument to map is a square. Square is a function, so it takes a function as its parameter. That's why it's called higher order function. So its scientific nature really supports more complicated expressive power in this kind of paradigm. All right, and also it has direct association with the lambda calculus. Lambda calculus is the mathematical foundation of functional programming language. So that's why we feel scientifically it's really rigorous. And you can actually code and run it. The reason is that even though it's a one-liner, it's science, it's big data oriented, it can also run. It has a realistic kind of a relevance. So we can actually rely on it and see what will be the outcome of this one-liner. So it's not just a scientific academic exercise. It's really something that we can rely on to run and to see and to get the result. So it's more tangible. So in another perspective, we can think about this one-liner as an executable specification. So specification and implementation, as software engineer, I think they cannot be more familiar to us, right? And it's not just a specification, it's executable. It can be run by a computer, right? So you can see in one summary, one sentence, this one above one-liner, it's succinct and semantically rich. It has the scientific content. It also has the mathematical rigor, as I mentioned, backed up by lambda calculus. So Professor Chen proposed a theoretical framework called the C2 framework. Inside the C2 framework, there is a mechanism called a C2 morphism. It is a mathematically enriched map, can be implemented through the higher order function of map. I will not branch into that too much based on our time limit, but if you would like to, please let me know later on. And I just say one thing. We are talking about a situation, but you may ask, this one expression looks like just a simple program. So is it a situation? I would say that even though this is simple, but it contains all the grains of truth towards a situation. So let's think about this situation. As a paper reviewer, we were busy with the reviewing a task assigned to us. So we can use the higher order function under the functional paradigm to describe a paper review situation. So you can see that the map is higher order function. The review is the review order, is the review kind of action, right? When you actually map it into the list of papers, you get the reviewed results. And then when you get the average of the reviewed results, you get the review. So this is basically a semantically rich, in the same time, very succinct, simple to grasp sort of expression. So I just use a little bit of the annotation here to help us to understand exactly what this simple liner, one-liner, can do for us. And then if you actually have a little bit more kind of experience with functional paradigm, you know that this average basically is a reduced function, synthesize. Right? You have many reviews already because map it into this paper. You get a review for paper 1, paper 2, all the way to paper N. And then you average the reviewed results. Then you get the final review. So that's basically what I would like to say. Number 2, this review, you can see this paper from paper 0 to paper N. It really kind of give us a dynamic data stream because at real world, you can actually get many papers as you like. And in functional paradigm, there is a mechanism called a lazy evaluation. Lazy evaluation, if you know that, it can be used to handle infinite infinite list. But here, because dynamic, because people don't know how many papers in static time will be there to be reviewed. So the lazy evaluation can do it very efficiently. So I just kind of would like to pinpoint some very simple, yet I believe realistic backup for the theoretical framework called C2, where Professor Chen just mentioned and proposed in his previous, I would say, influential paper. And with that, I conclude my part of the discussion, and I would like to transfer it to our next speaker, Professor Xuanzhe Liu. Thank you.
So many thanks. Thanks for Ming for your positive stakes to me. And can you hear? Can you see me sharing? Oops. There might be maybe some problems. So my theme is about the ethical AI in the SSE. This is really a very big topic, and it can cover a lot of things. First, we talk about the AI empowered SSE, not only because we can see in the past a few days, a few years, we can see the burst of artificial intelligence, and especially based on the big data. And I can see the artificial intelligence can help improve the SSE for many various aspects. AI can help understand requirements of the users by learning user behaviors, not only collectively from the wisdom and also the individual for personalization of the services. And it can also reduce manual jobs in labor-intensive software development activities. With AI, we can use some code completion and also mine the software repositories to find more development skills and knowledge. And it can also help improve the operational the operational aspects of running systems. For example, decision making to adapt to their external environments. However, when we embrace artificial intelligence in software service engineering, we can also see many non-trivial ethical issues with AI. For example, it is not really a typical trolley problem is the autonomous driving service. We can free in our hands and labor and save enough time on the car and to watch videos, to read books and listen to the music. However, when an accident happens, how can we judge the legal liability of human and the driving software of an accident? How we can judge if the accident is due to the carelessness of the driver or from the mistakes or the bugs of the software? And also in the autonomous driving service, and you can make some very difficult decisions for the AI which related to the ethical problems. You can sense the external environment, and you can find some person and some people in front of you or around the car, and you may hit them. At the time, you can drive forward, or you will hit one person. Diverge, you will hit another. Which one do you want to hit? Nobody, right? And what if there is a child or an adult or two people with one? How does the software can make the ultimate decision, right? And also we can make some problems with the decision-making services. Currently we can use the AI to help make the requirements engineering to understand our users better. But when we embrace AI, for example, in the requirements engineering, we can face a problem that the AI may make prejudice of gender, age, because all the decisions are made from the data collected, and how to guarantee the unbiased requirements engineering or user profiling. And one problem behind this, or whether we can legally collect the data, right? We know there are so many technologies such as federated learning and cross-sense learning to help reduce the privacy risk. But also we can use some policies or laws like the GDPR or CCPA that relate to the ethical AI in the services software engineering. So this is really very dilemma when we embrace AI in our software service engineering, and how can we make the human and the machine symbiosis? It means that we should embrace the AI, but we must ensure that the AI cannot violate any unexpected ethical problems such as privacy, correctness, trust, reliability, surveillance, and many, many other things, right? So from my point of view, that the ethical AI should be a cross-cutting issues through all the life cycles of software services engineering. At the very beginning of the requirements engineering, we may adopt some community-driven approach to harvesting human wisdom through the data, information, knowledge, and wisdom hierarchy. But this means that we can collect some data from the people with legal constraints, and we should better analyze the data and to avoid some unbiased things. This not only from the just only the machine learning or the deep learning technologies, but we must use some human intervention and to add some policies to make the human in the loop to help to understanding whether AI can violate some ethical problems, right? And also as a development, the developers and the architects can design software systems with advanced technologies that preserve correctness, completeness, safety, usability, privacy, security, and trust, and so on, right? But it means that when we make some we programming, right? We must take into account all these issues, and also some of the requirements or the issues come from the understanding and the sensing of the environment and the users. And we should mix our development activities with better intelligent IDs or some other problems or some technologies to help us to better mix our developers to and architects to take into account ethical issues when we design software. And the most important thing is the runtime, because we know that the runtime systems should detect or predict potential risks of the AI and make adequate decisions according to the situation, just as Professor Chang and Ming talked about the situation, because the AI should better understand all the situations and make the ethical problems, issues as a first-class entity when they make some adaptations. By this means, we make the runtime as the software services systems should measure the and model and measure the external environments and make some analysis and make some adaptations, right? So I can show you some example in our past few years work, and one paper from UPCOM 2019. And a very typical example is of the we use input method, right, every day. When we mix the input method, we enjoy the services of the predict the next word to input. For example, three persons, they have their tonight I will go to, and their input method will recommend some words and phrases to complete the whole sentences. For example, if they're a student major in chemistry, if they're tonight, I will go to the recommendation should be experiment, and the programmer is the recommendation should be coding, and maybe a beautiful girl, the recommendation should be shopping. And today, when we use any input method such as Google input method or any other and Zogo in China, and we know that all these decisions are made by the input method provider, and they collect some data from the users to the cloud. In the past, it was okay, but as I mentioned, because of the ethical issues of the privacy violation, especially with laws such as GDPR and CCPA, right? This data cannot be only easily collected and analyzed. Also, we know we can take into some ethical problems. We make the model should be better personalization. If we collect on the cloud, the personalization cannot be done very easily due to many costs, right? So With this work, we make the program to help to help preserve the privacy. That is a key ethical issues of the users. We do not collect the data from the cloud, but we use some public data such as Wikipedia and Twitter to train some language models and push this data, these models and compress the models on the smartphone. And we call this on-device training. And with the on-device training inference with personal data, and this data will not be uploaded to the cloud anymore. And we also make some algorithms, make the deploy on Android smartphones and smartwatch, and helps to preserve the accuracy. And we use a million user concurrent learning and to share the model in a very safe way. And we compared to the original solution, we can improve the accuracy of about 60% on 50 million users over commercial IME app, and only 1% loss compared to all on-cloud learning with private data, right? And also we have some more examples such as privacy, preserving e-commerce to help the ethical issues. And we published a paper on WW 2021, and also with the autonomous camera surveillance, and in our Mobisys paper last year. And if you have any interest, you can go to the paper. So what about the future? Just now, aside, the ethical issue should be a cross-cutting aspects of all life cycles of the SSE. And I wrote a very famous address from Abraham Lincoln. Lincoln's Gettysburg Address is governed by the people, of the people, and for the people. I just take the sentence and make some transformations. So ethical AI by SSE, of SSE, and for SSE. And by this means that we mix the AI issues all in SSE, modeling and mirroring ethical issues in SSE through the whole life cycle. And we making SSE more intelligent and robust at the system level. And we should developing some SSE tools and powerful governance too to make sure all the ethical issues should be protected and preserved in the whole life cycle of SSE. So the next heaven or hell when we embrace AI in our SSE, I think it should be heaven, not heaven, but we should take into account of the ethical issues and avoid to falling into the hell. Okay, this is my end of my sharing. Thank you.
Hello. Yeah. Thanks, Shenzhen. And I'm going to talking about a little bit opinion about the human behavior-driven requirements engineering in SSE. Next. Because of the development of the internet, especially the Internet of Things. Sorry, the slides is not correct. Yeah, there's some problem. Okay, sorry about some technical issues. Currently, because of development of internet, especially the Internet of Things, new applications are expected and in fact are emerging, like as shown as the smart city, smart buildings, smart health, smart home, etc. Along with these innovative applications, the next generation of software services are designed to be context aware and situation aware. That leads to a new paradigm of software services engineering. Yeah, this is the main topic of this panel. Next. These desired software services are asked to have some necessary features. For example, they should be human-centric, as the services are normally to help in human daily activities. This service should be able to capture the intentions of the users, and more importantly, to be able to observe the humans' daily behaviors. Second, the services should be adjustable for responding the changing context. In summary, better service delivery asks for knowing the environment, knowing the resources that they can use, and knowing the human that the service for, and it should provide adaptive, unobtrusive service with high accuracy. Next. So how to design such service system? How to figure out the requirement of such kind of services? It seems we need to do a kind of plan for the service delivery according to the changing context and the changing behavior of the user. In fact, this is a process of planning of or decision making. In some sense, requirements engineering seems to be of help. However, currently, when doing requirements engineering, we almost assume that either a contract goal is preset for a whole system and is choosing from a set of user goals. So those requirements engineering approaches focus on developing specification of the whole system. But when we think about the situation of the smart home, the new generation application, such heavyweight methods are not suitable for on-demand service delivery. Of course, we also can choose predefined. We can choose the way to do the predefined the services in advance. But in this way, the services are limited within the scope of the predefined set, and they are not target. These services are not targeted and not personalized. Next, what are the challenges for the new generation of services? We have to admit that the service should be human behavior driven, and they need to do the planning and delivering on demand. Concretely, such services are asked to assist human activities in everyday life, so that such assistive services need to reason about human behaviors. In one word, the service systems should be of adaptation. Next. Let's go a little bit about the human behavior-driven requirements engineering. As shown in the diagram in the right-hand side, the requirements engineering should be done in an adaptive way. The three levels in this diagram are at the bottom is a more environment model level. That is for modeling. That is for modeling the human behavior and the resources and the context. So that with these models, the system know the situations of the service delivery. The second level, the middle level, is the service delivery level, and the upmost level is the planning level. There are two control loops in this diagram. The feed-forward control loop and also the feedback control loop. For the feed-forward control loop is for observing the environment, detecting the human behavior, etc. And the feedback control loop is for sensing the behavior of sensing the service that has been delivered. So in this way, when the requirements engineering can be done like this way, when the system detects specific actions of human, the requirements engineering process then make a plan on the service delivery according to current environment and the resources in hand, and then provide the service accordingly. But the challenge here is making plan and the service delivery need to be very timely and can be predictive. So that is a kind of online requirements engineering for the behavior-driven requirements engineering. That is, it is needed to integrate requirements engineering process into the service delivery process. That is asked for a very lightweight requirements engineering methods that is also for ensuring the accuracy of the service delivery. Next. So that is what I want to share with you about the human behavior-driven requirements engineering. So thank you. Let's let the stage to Paula. Yeah, please.
Thank you, Zijin, for your presentation. So let me go full screen. Now, I'm now presenting this discussion about handling ambiguities and uncertainties in software service. I'm Paolo Ceravo from the University of Milan in Italy. As we have seen in the previous talks, software services are like bathed into a stream of continuous evolving operating conditions. And this flow is never static and rarely is recurrent. So we may have both external and internal conditions that can change, like, for example, the data distribution of the injected inputs is an external condition, or the allocated resource is an internal condition that may evolve during time. So it is clear that handling uncertainty is an important capability for ultra-agile situation-aware platforms, like they were named previously by Carl. And this implies that we have procedures for handling and representing uncertainty. So we know that scholars and engineers has reflected a lot about uncertainty. Uncertainty falls at the meta level in respect to threat, because it arises when knowledge does not provide us enough information about a statement in order to decide if a statement is true or not. So uncertainty can be encoded as the level of certainty we have about specific statements, the level of certainty a system has about specific statements. The nature of uncertainty can be classified as aleatory. So in this case, it is intrinsic to the observed world, like, for example, the variability of a population is something that is intrinsic. Or it could be considered as epistemic if it comes from a limited knowledge we have. It could be a lack of information, it could be ambiguity in the interpretation, like in languages, natural language, and so on. The source of uncertainty can be objective if it is related to a repeatable observation, or it can be subjective if it derives from informal evaluations that are done by agents. Also, uncertainty can be contingent if it is related to a specific situation, or can be generic if it refers to situations that are summaries about trend and reporting about regularities in the world. So in any case, we are not completely satisfied with the way we manage uncertainty, because it is clear we have multiple formal theories that can be adopted. The specialists know very well the intersection and the disjointnesses between these theories, but depending on the applications and also sometimes of the traditions, the mathematical and formal tools that we can apply are different. So these make the interoperability between the application more difficult from an engineering point of view. Just to give you a couple of examples, think about using your knowledge about territory and probabilities in order to complement the estimations of a tracking technology. So this tracking technology will provide you an area where the user may be placed. Then your knowledge about the territory will allow you to understand that is less likely it will be in some sections of this area, like in the sea or far from the roads and the passages. However, it will be nice if we could make such an inference system able to adapt according to the data he is ingesting. For example, a day where you have a lot of traffic may be significantly different from a day where everything is flowing very, very easily. Or to give you another example, think about using the perceptive knowledge, the approximate knowledge that is provided by fuzzy rules in order to insert some level of adaptation to an auto-scale procedure of a cloud platform. So maybe in combination with some reinforcement learning, you can readapt your rules in order to auto-scale the resource depending on some external conditions. And in this case, it will be very important if the system is able to understand which is the level of uncertainty that is deriving from having a specific decision. So for this reason, we think that the most important challenges we have if we want to somehow control the stream of changing operating conditions is about working on consistent techniques for combining uncertainty models of different types, but also introducing some level of self-consciousness to intelligent procedures that have to assess, for example, the uncertainty level of some specific decisions they are providing, or the concept drift. So when the models they are using should be updated because they are no more accurate. At the same on the same line, we would like to have intelligent procedures that are self-conscious about the role that uncertainty has in taking decision in combination with other requirements. So, for example, think about, as we say, an auto-scale platform, an auto-scale component of the platform, and this has to conciliate multiple requirements It could be the time, it could be the computational resources, the uncertainty level that is acceptable, that can be accepted by the system, is another component that should be included in the process of taking decisions. So thank you for your attention. I'll be available during the open floor section for answering questions. And now let me leave the floor to Ron Chan. Thank you.
Thank you, Paolo. So next slide, please. So the chart lists the 7 SSE R&D themes that we advocate based on our collective observation of related ongoing technology trends and the new challenging open issues. We know that operational excellence is key to the success of all software services in practice, though that is beyond the scope of conventional software engineering. Enterprise services computing needs are main drivers of our composition of the 7 things. So that's basically my preparation for the opening statement.
Okay, now since we had the technical difficulties earlier, so we're going to run a little bit over time. After this session, there's only we have 8 hours of break, so I think we can spend another maybe 8-10 minutes to entertain questions. Actually, I have immediate question to Rong Chen. You try to be brief, but you advocate the operational efficiency, for business installation. So my question to you is, for us, we work in service computing. We always said service is the first class citizen. Do you think, or should microservices be the first class deliverables of software engineering projects in the business sense?
Thank you, Carl, for the good question. In terms of operations management, I think of microservices as individually administered composable API services, which can be implemented by containers technologies or non-container technologies. I think such microservices should be first-class deliverables of SSE projects, since full-stack operations management complexity of our target software services is increasing exponentially. For example, creating human-embedded software services by composing SSE technologies is just too complex to be practical in the context of enterprise computing. So the approach of delivering such services via manageable and consumable composite microservices offers the most promising solution. So both the client and provider must be able to consume these software services easily. Okay, that's my answer.
All right. So I think the floor is open. Now I'm going to check to see if any questions from the audience. Or otherwise, I think we've been working together on this for several months already. We still try to learn from each other. So you have questions for any of, just any question you would like to also take this opportunity to clarify. Sumi, I see you're nodding your head.
Put me on mute here. So I have a question. If I may ask Paolo, is that okay, Carl? Can we?
Yeah. Okay. You ask Paolo. Okay, that's fine.
So definitely, as we move on to these new application areas with microservices, uncertainty comes to haunt us. And uncertainty is a big problem. And I'm just wondering, what do you think, Paul, about engaging the developers and the DevOps in uncertainty from a programmatic point of view? Like in a short word, like how do you program under uncertainty? Theoretically, we understand the issue and we have to cope with uncertainty and we have to manage it and tame it. But programmatically, like developers understand a paradigm, a programming language, like Huang Ming mentioned, is like a functional, not functional. So what is the first order of action here? How can programmers deal with or program under uncertainty?
Yeah, thank you, Sumi. I think it's a very interesting question. We have developed along the last century a lot of knowledge as humans in terms of the scientific method and the experimental inference that we can infer from the observations. And all this knowledge is not always used when we develop programming languages or also think about some way of using machine learning. So I think the notion of verification, the notion of that when you are processing some data, you also have to verify if some conditions are true or not. This is something that we should consider more also in the programming practice. Now, the idea that, okay, you take a decision by observing something that is in the external environment, but also you test if this decision is solid enough to be taken, or at least which are the effects that you can expect from this decision.
Thank you. Thank you, Paulo, for answering Sumi's question. We may have time for just one last question, I think. Well, we'll give to Jinzhi. So you can ask the last question. We can conclude this evening.
In fact, I have a question for Carl and also Hua. And I know you have published papers on situation analytics. I would like to know what was the main features and the main challenges, and because that is led to a new paradigm. And I would like to know the main features so that the people can focus on the research on these topics.
Should I go first? Wow.
Yeah.
Okay. Let me expand in this way. I think in terms of the challenges and the main feature is really our dream to be able to offer individualized service. So this should go beyond what we know as the so-called personalized service or personalized web. We enumerate all different kinds of parameters, and we parameter range over a set of values. That is still very static. I think in the IoT era, since the environment is so volatile, we never have a static environment. We can always expect people will evolve, people grow, people will not behave the same. So remember earlier I talked about the environmental context and the behavior context. What we really need to know in order to offer individual service, what the individual really wants, really needs. So we need to be able to really understand or be able to infer the person's mental state, your customer's mental state, or the intention or the desire. So in my definition of a situation, as I explained earlier, it's a three tuple. It's a mental state, mental context, environmental context, and behavior context. So situation or situ paradigm is really a functional paradigm in the sense. That's why Hua talked about functional paradigm, because situation is a functional mapping. You map the environmental context and the behavior context into your mental context, right? So it's very naturally you can use a functional paradigm to hopefully be able to implement this paradigm. So the environment is always changing, and behavior never stay the same. So you can never enumerate all the parameters, like in parameterization, right? You say personalized service, so we enumerate over all these parameters. In the IoT paradigm, such a more versatile, also a volatile environment, You cannot expect data keep on coming in, keep on streaming in. How do we handle that? Okay, and the environment, the parameter may be added, may be subject. No, so you have to be able to address such a dynamic behavior from the environment and a human being. So I think that's a challenge, but this also gives us the opportunity to offer much better final grant services that meeting the human needs. Hua, you can conclude this session if you have anything to add.
Thank you, Professor Chen. Thank you, Professor Jin, for your very good question. I think as a leading researcher in the world in software engineering and requirement engineering, I learned a lot from your work, reading the paper. So that's why I'm wondering whether this functional situation may have a good fit in this on-demand human behavior-driven requirements engineering field. So that's actually, I was trying to present the feasibility of using the functional expression. So functional expression is just like a poem, very short, right, one line, but it has all this ingredients that a prose or a long composition can express, encapsulated in just, for example, one poem. So, but that poem has some mathematical rigor. So it's just a form. So when we say 10 sentences, the chance we make mistakes is way bigger than just one sentence. So that's why I think maybe it can help to help with the software engineering, requirement engineering to shorten millions of lines of documents into shorter manner and with rigor. That's my comments. Thank you.
Yeah, thank you. Thank
so
you
I hope that answer Jinzi your question.
Yeah,
we are really short of time, but I think we really. I personally enjoy this session, this plenary session. I think we, even after we wrote the paper, we still have questions about many things we wrote about, because it's such a broad area, but with ample opportunities. So I hope that the audience can also learn something from this panel, and you can feel free to touch base with any of the panelists here, and then hopefully we'll come back next year and we can continue our discussion and see what are the new source and new advances in the software service engineering. And with that, I hope if you don't have any other questions, I will just conclude this session. And thank you all for participating and your contribution to the panel. Thank you.
Thank you, Carl.
Thank you.
Thank you all.
Take care, everyone.
Thank you, Carl, a lot for organizing
Bye.
this.
Thank you. Take care.